Welcome back, mathematicians. In this video, we're going to look at absolute value inequalities, and we're going to focus on the less than inequalities. In other words, we're going to have the absolute value of some algebraic expression, which is less than or perhaps less than or equal to some constant. In this case, we're going to look at the absolute value of x is less than 3. And we're going to use this in order to understand how to solve an absolute value inequality. So I like to look at this in terms of distance. So this means the values that satisfy this inequality have a distance from 0 on the number line less than 3 units. So let's look at our number line. We put 0 on our number line, and we look at values that have a distance of 3 on our number line as our boundaries. So this will be positive 3, which has a distance of 3 units from 0, and also negative 3, which has a distance of 3 units from 0. But we're looking not only for values that have a distance of equal to 3, but we're looking at values that have a distance that is less than 3. So that would be represented as 2 or 1 and all the decimals in between, and also negative 1 and negative 2 and all the decimals in between. However, we are not including 3 or negative 3 in our solution set because of the fact that we do not have an equal to part in our inequality. So that's why we would put parentheses as boundaries on negative 3 and positive 3. What we have here now, we've converted this absolute value inequality into a compound inequality. In other words, what I'm saying is that x is going to be greater than negative 3 and x is going to be less than positive 3. Another way to write that would be x is going to be greater than negative 3 and less than positive 3. So we can write the and inequality in either form. So let's come up with a rule that will help us solve absolute value inequalities. So we're going to let u be an algebraic expression. Then the absolute value of u less than some constant a is equivalent to this compound inequality, which is u is less than a but greater than the opposite of a. So all less than absolute value inequalities can be converted to that and compound inequality. Let's now use that rule in order to solve this absolute value inequality. So what we have here is a variable expression, and I'm just going to, for a moment, just let that equal u. So we've got this variable expression u, which is going to be the absolute value that is less than 2. So I'm going to use my number line to help illustrate what I have. I've got 0 on my number line. I've got 2 and negative 2, which have a distance of 2 units from 0 on my number line, but I'm looking for values that have a distance of less than 2 units from 0 on my number line, which would be all the values in between negative 2 and positive 2. Now, because I do not have an equal to part on my inequality, I am not including 2 or negative 2 in that set. So what I'm doing now is I'm converting this from that number line to my compound inequality. So what I have is u is going to be less than 2 and u is greater than negative 2. So this is just another way in which to do this so that you don't necessarily need to memorize a rule. We're going to now replace the u with 1 plus 4t, which is less than 2, and 1 plus 4t is greater than negative 2. And now you go ahead and solve these. So we're going to solve this by subtracting 1 to both sides, and what you'll notice is that both inequalities, we're going to do the same steps for both. So what we get is the 1 canceling out on the left, and we have 4t is less than 1, and 4t is greater than negative 3. Then we're going to divide by 4 to both inequalities. And what we get is t is less than 1/4, and t is greater than negative 3/4. Now, alternatively, I could have, at the very early stage, rewritten this compound inequality with the word and. I could have rewritten it as u is less than 2, but greater than negative 2. And then replaced u with the 1 plus 4t. So negative 2 is less than 1 plus 4t, which is less than 2, and then solve the inequality that way. And if I do this, again, I'm going to solve by subtracting 1 to all 3 sides. So I get negative 3 is less than 4t, which is less than 1, and then I divide by 4 to all three sides. Don't forget to reverse the inequality symbol anytime you multiply or divide by a negative. So I have negative 3/4 is less than t, which is less than 1/4. So these both are the solution set, just written in a different way. Now you might be asked to convert the solution set to interval notation. And in that case, for interval notation, the solution set would be from negative 3/4 to positive 1/4. So in this case, we have a boundary, a left boundary, and a right boundary of the solution set. But since we cannot equal those boundaries, since there's no equal to part in the inequality symbol, we use parentheses for those boundaries. All right, guys, good luck.